Students, welcome to Hari Chemistry. So myself Dr. Hari Prasad. So today's session we will discuss some basic concepts of chemistry. This is the PYQ series questions, April 2025 session, and also we will discuss January session, all the questions in the mains level questions, right? Okay. Now the question is, the first question, student, the amount of calcium oxide produced on heating 150 kilogram of limestone, it is 75% pure. So he is asking amount of calcium oxide when heated of calcium carbonate with 150 kilogram, right? So simple question, student, right? So solution we will discuss. Calcium carbonate solid on heating around 1283 Kelvin temperature, it will produce calcium oxide, or we can call it PYQs. Okay, right. So usually, student, this is what 1 mole of CaCO3 gives 1 mole of CaO. That means, student, 100 gram CaCO3 gives 56 grams of CaO. But the question is, student, here we are taking 150 kilogram of limestone, but it is a 75% pure, it is not 100%, right? So 150 into 10 to the power of 3 grams into kilograms converted into grams, 75 divided by 100, student. Okay. So student, here two zeros get cancelled, then it becomes, student, 150 into 10 into 75 grams. So now we will multiply 75 into 15, student. 5 5s are 25, and this will be 35 to 37, and 5 and 7, student. And this will be, so 1125. So into 20, student, then we will get 112500 gram, right? So now we will calculate from this how much amount of CaO will be produced. That's it, right? Now 100 gram will give 56 grams of CaO, then 112500 grams of CaCO3 gives how much? Apply unitary method, student. 11250 into 56 grams of CaO divided by 100 gram of CaCO3. Two zeros get cancelled, student. Just multiply 1125 into 56. You will get the answer in terms of gram, then convert into kilogram. Okay. So 1125 into 56, student. So that is equal to 5 6 30, 6 2 12, 15, and 6 1 7, and this will be 6750 into 5 5 25, 5 2 10 plus 2 12, and 5 1 1, right? So that will be 6 and 5. Now look at, student, this will be 10, this will be 10, and this will be 63, right? Now here we are getting 63,000 grams. Convert into kilogram, student. So that answer will be 63 gram, right? So here the amount of calcium oxide produced on heating of 150 kilogram of limestone, student, 63 kilograms is produced, right? Okay, right. Next, student, right? So 20 ml of sodium iodide solution gave 4.74 gram silver iodide. When treated with the excess of silver nitrate solution, the molarity of the sodium iodide solution is asking. So he is asking molarity, student, right? So here we have sodium iodide solution, right? So this is sodium iodide solution is mixed with AgNO3 aqueous. So usually we will get, student, a dark yellow color precipitate, that will be sodium silver iodide. So it is a dark yellow colored precipitate. Dark yellow colored precipitate. Now, student, the question is asking relation with only sodium iodide and silver iodide. Am I correct? Right. Okay. Right, student. So look at, student, 20 ml of sodium iodide solution gave 4.74 grams of silver iodide. Now, so this silver iodide given, student, just we will take the relation. So 1 mole of NaI will give 1 mole of AgI. But the given question, student, how many moles of sodium iodide will give 4.74 grams of silver iodide? This is we will calculate. So number of moles of AgI, student, that is equal to weight by molar mass. So AgI molar mass will be 235, student. So that will be 108 plus 127. So approximate you can take, student. This will be 470 into 10 power minus 2 you can take, student. This will be 235. So this will be 2, right? So our answer will be 235 1ja, right? So our answer will be 0.02 moles, right? So means here, so 0.02 moles of AgI produced. From 1 mole to 1 mole means it is also produced from what, student? So 0.0 moles of sodium iodide only. Okay, now, right? Now we have 0.02 moles of sodium iodide. Moles we know. Then what is asking, student? Is asking the molarity of sodium iodide. So molarity is equal to, student, number of moles into 1000 divided by volume of solution is what, student? 20, right? So 20 1ja 20, 20 1ja 20 50 ja, right? Now if you multiply, student, 0.02 into 50, so then answer in terms of what, student? 1 0 get cancelled, then 0.2 into 5. So answer is, student, 1 mole per liter, right? So answer will be what, student? 1 molar. So simple answer is, student, answer is what? 1 molar, right? So this is the question, second question. So simple mole only, mole concept only we use, right? Next, look at the third question, student. 0.1 mole of the following given antiviral compound P will weigh dash in, right? Okay, simple. This is also simple, student, right? So solution we will discuss, right? So weight is equal to, student, in terms of moles, weight is equal to, student, number of moles into molar mass. Number of moles into molar mass, right? Already number of moles of antiviral compound is given 0.1 mole into molar mass. We need to calculate, student. Just count the number of carbon atom and nitrogen and remaining other atom. Just multiply with its atomic mass. We will get the answer, right? So now here, student, 1 carbon, 2, 3, 4, 5, 6, 7, 8, 9. So 9 carbon atom we have, student. 12 carbon atom into 9 plus number of nitrogen we will calculate, student, 1, 2. So 2 nitrogen atom, student, into 14 plus 1 fluorine atom, that is 19 plus oxygen atom you can check 1, 2, 3, 4, 5. So 16 oxygen atom into 5 plus, and remaining will be 127 iodine plus number of hydrogen we will count, student. 1 here 2, here 3, here 4, 5 plus 2, 5 plus 5 plus 1, 6 plus 2, 8 plus 1, 9, right? 9 hydrogens, right? All together, student. So this will be 108 plus 28 plus 19 plus 16 paisa 80 plus 127 plus 9. So all together, student, all together this will be 136 plus 19, 136 plus 19, 155 plus 80 235 plus 9, 235 plus 9, 244. So 244 plus 127 student, around it will be 1, so 371 student, around it will be 371, right? So molar mass will be 371 student, so that you can multiply, so this will be 37.1 student, right? So in terms of grams only, but the given question is student dash into 10 power minus 1, I can write this is 371 into 10 power minus 1, so answer will be 371 into 10 power minus 1. Our answer is what student? 371 into 10 power minus 1, right? Clear student, right? Next we will move to the next question student. Among 10 power minus 9 gram of each of the following elements, which one will have the highest number of atoms is asking, right? Okay, so this is also simple question student, right? So conceptual question only, right? So generally student, number of moles is equal to, or number of atoms is equal to, I will write number of moles into Avogadro number, or I can write student weight by molar mass into Avogadro number, right? So simple student, number of atoms is inversely proportionality to molar mass, number of atoms inversely proportionality to 1 by molar mass. Here the beautiful thing is weight of each element is given as a same only, so that's why we will take the relation student, number of atoms is inversely proportionality to molar mass. The element which is having lower mass, it is having the highest number of atoms, that's it, simple, right? So the element which has lowest molar mass, then it has highest number of atoms. That's it student, this is the concept. Now so look at student, lead will be 207 student, Prasadium will be around 141, polonium will be around 201 student, platinum will be 190, 197 something. So from the given all student, so Prasodium has lowest molar mass, so that's why Prasodium is our answer. Prasodium is our answer. Simple concept student. Number of atoms is inversely proportionality to molar mass because of each of the element having the same mass only. So then I will take the direct relation, number of atoms inversely proportionality to 1 by molar mass, right? Next student, fortification of food with iron is done during FeSO4.7H2O. The mass in grams of FeSO4.7H2O required to achieve 12 ppm of iron in 150 kilogram of it, right? Okay. So first of all student, so what is mean by fortification of food? So fortification of food means nothing but student, right? Iron is present or iron is added to the food. So means iron is which is present in the food only. That is a simple fortification of food with iron. Okay, right. So he is asking student, what is the mass of FeSO4 in grams? He is asking, right? Okay, right student. The given student 12 ppm of iron in 150 grams of wheat, right? Okay. So now look at student. So the meaning of 12 ppm. 12 ppm means student in terms of grams, 12 grams, or you can use the direct formula, student, that is parts per million. We have one formula, parts per million is equal to weight of solute divided by weight of solution. That is nothing but, student, weight of solvent you can take into 10 to the power of 6, or you can go through directly simple, student. 12 ppm means nothing but, student, 12 grams of iron in 10 to the power of 6 grams, 10 to the power of 6 grams of compound present in 10 to 12 grams of iron present in 10 to the power of 6 grams of component. So 150, that is nothing but wheat. 150 into 10 to the power of grams of wheat contain how much iron? That's it, student. So that is equal to, student, 150 into 10 to the power of 3 grams into 12 divided by 10 to the power of 6, student. So 10 power 3 get cancelled, 10 power 3 remaining, student, right? So that is equal to 115 into 12 divided by 1000, student. Again we will cancel 1 0, student. Now so 12 into 15, that value will be 180. So divided by 100, 0 get cancelled, student. 1.8 grams of iron, right? Okay, so 150 kilogram of wheat contain 1.8 grams of iron. 150 kilograms of wheat contains, student, 1.8 grams of iron, right? Now our calculation should be what, student? In FeSO4 we will calculate it. Now look at, student. So FeSO4 molar mass we need to calculate, student. Around it will be a calculation. So just you will get, student, 1278 gram per mole, student, right? Okay, right. So 1278 gram per mole of FeSO4 dot 7H2O contains, student, 56 grams of iron, student. 56 grams of iron. So 1.8 grams of iron contain, what about the mass? How much? Right. Same unitary method, student. 278 into 1.8. So divided by 56, student, right? Just do the calculation, student. 278 56 multiplication divided by this, student. So 56 5s are 56 5s are, so 280 will come, student. So then we will go to the 56 4s are. So 56 4s are 24, 5 4s are 22, 24, student. So 224, right? Next, so remainder will be, student, around remainder will be 54. Remainder will be 54, right? Now you can take 0, student, right? So 56 9, so means it will be around 4.9, student. Just you can take, student, 4.9 multiplied with 1.8. So 4 9 18 you can multiply, student. 9 7 82, 4 8 32 plus 7 39. So 39, and this will be 9 and 4, student. So the overall answer will be 218. So this will be 8. So overall answer will be, student, 8.82. 8.82 grams. 8.82 gram. So question is asking in terms of grams only, student. Answer is 8.82 grams. Right. So next question, student. Right. So CaCO3 plus 2HCl gives rise to CaCl2 plus CO2 plus H2O. Consider the above reaction. What mass of CaCl2 will be formed if 250 ml of 0.76 m HCl reacts with 1000 grams of CaCO3. Right. Now look at, student. So this question is related to CaCO3 solid plus 2HCl gives rise to CaCl2 aqueous plus CO2 gas plus H2O liquid student. The question is asking directly related to calcium carbonate versus calcium chloride. Simple student. Right. Now the given question is student 1000 grams of CaCO3. Now we will calculate the number of moles of CaCO3. So that is equal to student weight by molar mass. So that is equal to student 10 moles of CaCO3. And HCl you can check student. HCl is given as 250 ml is given, right? So calculate number of moles. So molarity is equal to number of moles of HCl into 1000 divided by V in ml student. V in ml. So molarity is given student 0.96. Number of moles of HCl into 1000 divided by 250 student. 0 get cancel. 25 1 ja 25 4 sa. So then divided by 4 student. So this will be 0.19 mole student. 0.19 mole. So now as per the given data student, so here we have 10 mole, here we have 0.9 mole. So means HCl is completely consuming. So then we will apply limiting reagent concept. Simple student, right? Now student, 2 moles of HCl, 2 moles of HCl gives 2 moles of HCl gives 1 mole of CaCl2. Am I correct or not student? Right. Now how many moles we have? So 0.19 moles of HCl gives how many moles of CaCl2? That will be 0.9 into 1 divided by 2 student. So here is asking weight is asking. Weight is asking. So then mole only we have student. Just this will be mole of CaCO2. I will convert it into its molar mass. So that is equal to 0.19 into 111. Its molar mass student. So just you can multiply 111 into 19 student. Just we will get the answer 999. So this will be 111. So this is equal to student 10. This is equal to 11. So 2109. So after decimal student, so 21.09. So divided by 2 student. So our answer is approximately 10.5 something. 10.5 something. Right. So this is the answer for that above question student. Right. Check with the option. Option answer C is the right answer student. Right. Right. So next question student. This is the 7th question. 7th question. Right. Now look at student. So this is 1 2 3 4. So 1 2 3 4. 1 2 3 4 5 student. This is a 2 bromopentane. Alkali KOH is given. P is the major product student. So this is alkali KOH. So this is bromine student. Alkali KOH means elimination reaction student. Right. So here we have 2 possibilities. Here 1, here 2. So this is the possible major product is here student. So student we will get the major product is this is right. So 1 to 2 pentene is the major product to student. Right. So this is the major product. Then this major product on reaction with bromine student. So usually it is a cyclic reaction student. You will get the trans product, right? Anti-addition product you will get. So this is bromination. So you will get student. You will get product is 1 2. So you will get student 2,3 dibromopentane. 2,3 So dibromopentane. So it is the major product, student, right? It is the final product, right? Now what is asking, student? He is asking, this is 80%, right? So P is gives 80% is the major, but Q will give the 100% product, right? So simple, student, just you check the question here. This is 1 mole of this compound will give 1 mole. So this is the major product P, but this is, student, 80% only. 80% means nothing but, student, this will be so 0.8 mole, 0.8 mole, right? So why? Because, student, here 151 gram. So 151 gram is given, right? Now we will calculate the number of moles, student. 1, 2, 3, 4, 5. 5 carbon atoms are there. 60 plus 1 bromine is 80. 3 to 5, 5 to 7, 7 plus 3, 10, 10, 10, 10 plus 1, 11. So around it will be what, student? So 151, right? So that is equal to, student, 1 mole. So means 1 mole will give 1 mole only, but it is a 80% only, right? 80% means, student, that will be 1 mole into 80 by 100, student. 80 by 100. So that is equal to 8 by 10, student. It will be 0.8 mole, right? Now, so this 0.8 mole will give reaction with the bromine. We are getting the 100%. So now, student, you will get 100% means there is no loss. So now, student, you will get the 0.8 mole of this Q. So what is asking, student? What is the mass of product Q is asking? Just we need to calculate, student. 1, 2, 3, 4, 5. So here 151 we have. Addition, you can add one more bromine, student. 151 plus 80. 151 plus 80. That will be 231 gram. So now, student, mass of Q is equal to, student. So 0.8 into 231, student. So 231 into 8, you can multiply 8 3 is 24, 24, 8 3 is 24, 24, 8 2 is 16, 2, 18. So you will get, student, 184.8 grams of Q will be obtained. So mole to mole only ratio we are taking, student. 1 mole will give 1 mole, but the product yield will be 80% only. From this 80% of this is 0.8 mole, but this 0.8 mole of P will be converted into what, student? 100% only. So that's why our calculation will be 0.8 mole is the 100% only. So mole mass is asking, mole into molar mass, then we will get the answer in terms of gram. Answer will be 184.8 grams, student. Next, 8th question, student. Mass of magnesium required to produce 220 ml of hydrogen gas. Next question, student. The mass of magnesium required to produce 220 ml of hydrogen gas at STP on reaction with excess of dilute HCl. Right. So he is asking, student, mass of magnesium. Right. Now look at, student. Magnesium reacted with HCl gives MgCl2 plus H2 gas. Clear, student? So here the question is related to magnesium and H2 gas only, right? So 1 mole of Mg gives, reacted with excess of HCl, it will give 1 mole of H2 gas. But the given question, student, so is asking mass of magnesium is required to produce 220 ml, right? So now the given data, student, 220 ml of hydrogen gas is given. By using this, we will take the relation with the number of moles of magnesium, right? So 1 mole, 1 mole, right? So now, student, number of moles of H2 gas is equal, I can write, student, volume is given divided by volume at STP. Now 0, 0 get cancelled student. Now 22 divided by 20 to 40 moles. So that is equal to moles of magnesium only. Right now, moles of magnesium if I know, then if I multiply with the molar mass, then I will get the mass of magnesium only. Right now student, 22 divided by 20 to 40 into mass of moles of molar mass of magnesium is equal to what? 24. Then I will get student mass of magnesium, simplify. Okay now, right. Now look at student, this will be 4 6 and 4 5 60. Now you can multiply student, 22 6 132 and divided by 560 student. Now take 0, then I will take 0 point. Now 562 student 1120. Am I correct? Now this becomes student 200. Now take 1 0. So 563. So this becomes student 563. So 563 1500 and 1680. So remainder student 320. Remainder is what student? 320. Right. So now you can take 0 student. So it will be around 566. Right. So this will be 2. You can take approximately 0.23 grams. But the question in terms of is asking milligram. So now student, 0.23 into gram. 1 gram is equal to how many milligram? 10 power 3 milligram. So our answer will be 230 something. Right. So this will be dash will come 23 mg type right now. So by given options, option C is very closest to the given answer student. Our answer will be 236 milligram is the right answer. Okay now, right. So just we did simple Mg2, MgCl, Mg2, H2 gas only student, just basic mathematics only. Next, an organic compound weighing 500 mg produce 220 mg of CO2 on complete combustion. The percentage of composition of carbon in the compound is right. Okay, so just look at student, the question is an organic compound. Weighing of organic compound is given 500 mg. So produce 220 mg of CO2, right, on complete combustion, right. So we will go to the directly formula student because he is asking percentage of composition of carbon only, right. So we have percentage of carbon according to the Lipschitz method student. Percentage of carbon is equal to atomic mass of carbon divided by 44 into weight of CO2 divided by weight of our organic compound into 100. That's it. Now look at student, 12 divided by 44 into weight of CO2 given student 220 mg. Right. So okay, you can convert into milligram to gram, right. So 1 milligram is equal to 10 power minus 3 grams. 10 power minus 3 grams divided by weight of organic compound in terms of grams, that is equal to 500 into 10 power minus 3 grams into 100 student. This will get cancelled, right student. So 500 1 ja 100 5 sa, right. So now this becomes student 44 into 5 220. So 12 into 220 divided by 220 student get cancelled. Answer is student 12%. The composition of carbon in the compound is student, nearest integer is what? 12 is the right answer. Next question student. Butane reacts with oxygen to produce carbon dioxide and water following the equation given below. So that is C4H10 plus 13 by 2 O2 gas gives rise to 4 CO2 plus 5 H2O liquid. So the given data, student, 174 kg of butane is mixed with the 320 kg of O2. So he is asking the volume of water is formed in liter is asking. Right, okay. So equation is above, student. We will copy the equation as it is. So that is equal to C4H10 butane gas on complete combustion with what? Oxygen. So we will get carbon dioxide plus 5 moles of water in liquid. So question is asking in related to butane gas, water only, right? But limiting reagent is the parameter we need to concentrate, right? Now, so first we will calculate number of moles of C4H10, student. Here I will calculate number of moles of C4H10. So given in terms of kilogram, student, we need to convert into gram divided by 12 4 ja 48, 48 plus 10 58, student. So 58 1 ja 58 3 ja, student. So now this becomes 3 into 10 power 3 mole, student, of C4H10. Similarly, we will calculate, student, number of moles of O2. That is equal to, student, 320 into 10 power 3 divided by 32, student. So this will be 10 into 10 power 3 moles, student. 10 into 10 power 3 moles, right? So from this, so number of moles I got, this is, student, 3 into 10 power 3 moles. This will be 10 into 10 power 3 moles, right? Now, stoichiometric coefficient, student, here it will be 1, it will be 13 by 2, right? Now stoichiometric amount, student, that will be 3 into 10 power 3 by 1. This will be 10 into 10 power 3 divided by 13 into 2, student, right? So after simplification, student, this is our limiting reagent. After simplification, student, this is our limiting reagent, right? O2 is our, student. So limiting reagent is what? Oxygen is our limiting reagent. Excess of reagent is what? Butane. Okay, right, student. 13 by 2 moles of O2 gives 5 moles of H2O. Okay, now, right. Then 10 into 10 power 3 moles of O2 gives how much? So that is equal to, student, 10 into 10 power 3 into 5 divided by 13 by 2, it becomes, right? Now you will get, student, number of moles of H2O is equal to 5 to the 10, 10 into 10, 100. So then you will get, student, right, number of moles. Now, student, weight of H2O is equal to number of moles into molar mass only. So 10 to the power of 5 by 13 into 18. So this is the weight of H2O. Now, but he is asking, student, what is the volume of water formed in liter, right? So now, student, density of water is equal to, I can write, student, mass of water divided by volume of water, right? So that is equal to, student, density of water is given as what, student? 1 gram per 1 ml. 1 gram per 1 ml. That is equal to, student, 10 to the power of 5 into 18 divided by 13, right? So if volume will come, so then it becomes, student, then it becomes, student, 10 to the power of 5 into 18. So after simplification, student, we will get the closest answer is we will do one thing student, 13 by 18, 13 we will do. So this will be 13 1 ja 13. So this will be, remainder is 5 student, right? So take, this will be 13, 13 4 ja 52. So 13 4 ja 52, 13 3 ja we will take student, 13 3 ja. So we will take 13 3 ja 39. So remainder is 11. So then again we will take one more 0. So 13 7 ja 91. 13 8 ja 8 ja. So 21 101 student. So this will be 1.38. So 1.38 into 10 to the power of 5 ml student. Now can I write student, this will be 138 into 10 power 3 ml, or I can write answer is student 138 liter. So answer for this question student, 138 liter is the correct answer, right? Next question student, look at the next question. Right, look at student, the question is given as, on combustion of 0.210 grams of an organic compound containing carbon, nitrogen and oxygen gave 0.127 grams of H2O, 0.307 grams of CO2. Is asking the percentage of hydrogen and oxygen is asking. Okay, same we will apply the same concept student, Lipschitz method. So that is equal to percentage of hydrogen, I will go directly. Percentage of hydrogen, okay. So we will do percentage of carbon is equal to, that is student 12 divided by 44 into weight of CO2 given 0.30. So closest here I am taking student, and weight is given 0.21 into 100. So this will get cancelled student. This will be 3 7 ja and 3 10 ja. So now it becomes student, this becomes 4 11 4 ja 4 11 ja 4 25 ja. So this becomes student 250 into 12, 250 25 12 300. So 250 into 12. So this becomes student 0 10 500. This will be 0 5 2. So this will be 3000. So 3000 divided by 77 student. So first we will take 300, then we will do the multiply with the 10. 77 3 77 4 77 4, okay, 77 4 77 4 7 4 ja 28 308, okay. So not possible 4. So 77 3 we will take student. So this will be 21 7 3 ja 21 21 to 23. So 23. So that will be 231. That will be 231. So remainder will be 69. So this becomes student, this becomes 690. So 77 10 ja 770. So 77 9 ja 6 9 ja, so not possible 3.8. So this will be closest to the 38% student. Percentage of carbon is 38. So now similarly we will do the percentage of hydrogen. So that is 2 by 18 into 0.12 here I am taking, and 0.21 into 100 I am taking student. 4 3 ja 3 4 ja and 3 7 ja. So then it becomes student, then it becomes 2 9 ja and 250 ja. So this will be 200 into 2 400. So 400 divided by 63. 400 divided by 63. 400 divided by 63. So 63, 6 or 63, 7 not possible, 63, 3. So 18, 36, 36, 37. So this will be 378. 378. So 378 student, remainder is 22. Remainder is 22. You can take 0, 0. This value will be 63, 3. So 63, 3 6.3, 6.3 we are getting 6.3, we are getting 9 7 63. Okay, 6.3 we are getting. So percentage of hydrogen is equal to 6.3. So closest answer is hydrogen. Not possible. 53 we can eliminate, option is wrong, and we can eliminate option is wrong, and our answer may be either 2 or 4 only, right? So now here, based on the percentage of oxygen, that is equal to student 100 minus percentage of carbon plus percentage of hydrogen. Just mathematical calculation only, student. So that is equal to student 100 minus, I will take percentage of carbon will be 38 and this will be 6.3. So 38 plus 6, 43, 43.3. So 43.3 means around it will be more than 50. So now answer is 2 is the closest answer, student. You can write just mathematical calculation only. I did simply approximation only. So then our answer will be 6.72 and 53.41 is the closest answer. Right, next. On complete combustion, 1.0 grams of an organic compound X gave 1.46 grams of CO2 and 0.567 grams of H2O. The empirical formula of compound mass is asking, student. So here also we will do the same thing, student. So we will do the percentage of carbon. Percentage of carbon is equal to, this will be 12 divided by 44 into 1.46 divided by 1 into 100, student. This will be 4 3s, 4 11s, then 2 zeros get cancelled. So then it becomes 146 into 3. This will be 18, 4 3s are 12, 13, 13. This will be 438. So 438 divided by 11. So 11 4s are not possible, 11 3s are possible. 11 3s are 33, 33 means 108. So 108, 11 10s are not possible, 11 9s are. So this will be 99. So 99, 99, remainder will be 19. Remainder will be 19. Remainder will be 19 means if I take this will be 0. So this will be 11.11. So 11 point, right? Okay, so we will take approximately 39.18 something percentage, right? Now look at percentage of hydrogen. Percentage of hydrogen. That percentage of hydrogen is equal to same 2 by 18. So that means you can take 1 by 9 simply into 0.56 divided by 1 into 100, or you can take 7 also. So this, student, 2 zeros get cancelled. This will be 56 you can take. So 56 by 9. 56 by 9, 56 by 9, student, 56 by 9. So 9 7 ja 63, 9 6 ja 54, 9 6 ja 54, 9 6 ja 54. This becomes 2. This become 29 2 ja. So here I am taking hydrogen percentage will be 6.2. So that will be 6.2 percentage student. So then the total percentage is not equal to 100. Then we will go with that percentage of oxygen also present. So percentage of oxygen is equal to student 100 minus 39.18 plus 6.2. So 39.18 6.20 we will take. This will be 8, this will be 3, 5. So 45.38. So 100 minus 45.38 means student this will be 54.62 percentage. Right. So now this will be 39 divided by 12. Hydrogen will be 6.2 by 1 and oxygen will be 54.62 by 16. Right. So during the simplification student, that will be 39.18 divided by, so just we will get approximate here. I am writing student 3.2 and this will be 6.2 and this 54.62 divided by 16. So this will be closest will be 3.4 student. So take the smallest ratio student. This will be 3.2, this will be 3.2, this will be 3.2. So number of moles of carbon will be whole integer ratio only. So this will be 1, I will take this will be 2 and this will be 1. So our empirical formula will be CH2O student. Our empirical formula will be CH2O means carbon will be 12 and oxygen will be 16. 28 plus 2, that will be 30. So answer A is the right answer. I hope student we did all the model of questions. I think mathematical calculation also I did. So if you like this video student, so please share the video and like and comment on this writer. Now we will continue to the January session also student.